So today we're going to be talking about adding and subtracting linear expressions, and how can you add or subtract linear expressions is our essential question. So we're going to apply the properties of operations to add and subtract linear expressions and solve some real-life problems. Now, I don't want you to get too hung up right now when we're talking about linear expressions, okay? It's just going to be a fancy word, but we are going to keep doing what we have been doing already this week. We are going to be simplifying those algebraic expressions, and we're just going to be talking about that a little bit more in detail. So our key vocabulary here, a linear expression is an algebraic expression in which the exponent of the variable is 1. So when we have algebraic expressions, we can break algebraic expressions into two categories. They can either be linear expressions or they can be nonlinear expressions. By linear expressions, what we can say is that that comes from the word line, and these things can be classified as expressions of lines. Okay, so if we were to try and set these equal to y and graph them, we would end up with a straight line as our graph. Now, what's important to remember is the distinction between the linear expressions and the nonlinear expressions. When we're talking about linear expressions, we have this one very important key right here. The exponent of the variable has to be 1. If it's not 1, then it's not a linear expression. It would be nonlinear. If it is 1, then it can be linear. So as we look at this, we have negative 4x. So this x, even though it doesn't have an exponent written in right here, actually has a little invisible 1. So that is to the first power, which means that it is the only variable, and that variable is to the first power, which means that it is a linear expression. So as we look at this again, this 3x plus 5, again, there's a little invisible 1 right there, which makes that a linear expression. And on this last one as well, there's a little invisible 1 right there, which allows this to be linear. As we look at the nonlinear expressions, what we can see is we have an exponent of 2 here. Since 2 is not 1, that means that it cannot be linear. Here we have x to the third power, and here we have x to the first power. Well, what we want for a linear expression is that our variable is only to the first power. So as soon as we have that same variable raised to a power other than 1, that means that it's no longer linear. So this x to the third power beats out this x to the first power and makes it so that this whole expression here is still nonlinear. As we look at this next one right here, we can see this is to the fifth power, which again makes it nonlinear. So as we look at this, we're looking between the two distinctions here, that our linear expressions mean our variable, or our letter, as we have it inside here, has an exponent of 1 and no other number. Can't be bigger than 1, can't be smaller than 1. Has to be equal to 1. And if it doesn't meet that requirement, that means that it is non-linear. Okay? Okay, so when we're talking about adding linear expressions, that means we're going to take two expressions and we're going to add them together. Now, again, remember, our linear expressions means we're going to only be working with exponents of 1. We're not going to work with x squared or x cubed or any of those. Our linear expressions means that we're only working with exponents of 1. Now, as we go through this, we want to treat this just like we would treat any other kind of problem, okay? Even though right here we have one linear expression being added into another linear expression right here, it doesn't actually change what we're going to do. So as we look at this, we want to rewrite this using addition. So we're going to do this is now going to become x plus negative 2 plus 3x plus 8. Now, how I can treat these parentheses is as long as whatever is inside of the parentheses is as simplified as it gets, okay? And it's rewritten using only addition, okay? Only addition. That means I can actually cross out or kind of get rid of these outside parentheses, okay? So that's the conditions that I'm going to be looking for. The conditions we're looking for is that inside the parentheses, it's as simplified as it gets, and it's rewritten so that it uses only addition. As soon as we have that, then we can drop out those parentheses, and as we drop out those parentheses, we now have our larger expression, which is then going to be this x plus negative 2 plus 3x plus 8. So as we do that, we can now look at our terms for like terms, and then we can start combining our like terms to simplify this expression all the way. So as we do this, we're going to have x plus 3x, which is going to give me 4x, and I'm going to have negative 2 and 8, which is going to give me negative 6. And then as I add those two together, I'm just going to be completely done. Now as I look at this next equation over here, again, I need to rewrite this using addition. So I'm going to have minus 4y plus 3 plus 11y plus negative 5. Okay, this is as simplified as it gets, and there is written but with addition. This is as simplified as it gets, and we're using addition, which means now I can drop out these outside parentheses. So now I just have minus 4y plus 3 plus 11y plus negative 5. Okay, now again, I just go back and I look for my like terms. As I look at my like terms, I can then combine my like terms. So 3 and negative 5 becomes negative 2, and 11y and negative 4y is going to become 7y, and I am done. So as I look at this linear expression here, I again can rewrite this using addition. So I have 2 times by negative 7.5z plus 3 plus 5z plus negative 2. Okay, so this is as simplified as it gets, and I'm only using addition, so I can drop out those outside parentheses, so that becomes 5z plus negative 2. Now this piece over here, I still have to do this distribution before I can say that whole thing is simplified all the way. So this 2 times by that negative 7.5z is going to give me negative 15z, plus 2 times by 3 is going to give me 6. And now that is as simplified as it gets, and so I can drop out those outer parentheses. I can start looking for my like terms. I can see negative 15z and 5z is going to combine and give me negative 10z. And I can look at this and see that 6 and negative 2 can combine and give me positive 4. So that means that my answer is going to be negative 10z plus 4. Okay, go ahead and try these on your own. Once you've tried them on your own, go ahead and resume the video to make sure that your understanding lines up with mine. So as we do this, we're going to have x plus 3 plus 2x minus 1. I can rewrite this using just addition. So x plus 3 plus 2x plus negative 1. So this is as simplified as it gets in here, and this is as simplified as it gets in here. It's all rewritten using addition, so my outside parentheses can disappear. So I have x plus 3 plus 2x plus negative 1. I can now start looking for my like terms. As I look for my like terms, I will be able to combine those. I'll end up with 3x, and I'll have 3 plus negative 1, which will give me 2, and I am done. Okay, now as I look at this next one right here, I have negative 8x plus 4 plus 8z minus 7. So I can rewrite this as negative 8x plus 4 plus 8z plus negative 7. Now that I've done that, I can see that this is as simplified as it gets over here. So that we can drop out my outside parentheses. As I do that, I can look for my like terms in here. So I have negative 8x, I have 4, I have negative 7, and I have 8z. So as I rewrite this now, I'm going to end up with negative 8x plus negative 3 plus 8z. Okay, so I might want to just plug that into parentheses, and that will be good. Okay, now as I look at this next one here, I have 4 minus n plus 2 times by the quantity negative 5n plus 3. So as I look at this, I can rewrite this using addition, so it'll be 4 plus negative n plus 2 times by negative 5n will give me negative 10n, and 2 times by 3 is going to give me 6, so plus 6. I can come back and look for my like terms, so I have minus n and minus 10n, I have 4 and I have 6, so I can combine my like terms. Negative n and negative 10n will give me negative 11n, and as I combine 4 and 6 together, that will give me 10. So I can go ahead and add those together, so I have negative 11n plus 10. On this last one here, I have 1/2 times by the quantity w minus 6 plus 1/4 times by the quantity w plus 12. So as I do 1/2 times by w, I'll end up with 1/2 w. 1/2 times by negative 6 will give me plus negative 3. Then I'm going to end up with 1/4 times by w will give me plus 1/4 w. And 1/4 times by 12 will give me plus 3. So again, I go back and I look for like terms. So I see 1/2 w and 1/4 w. So 1/2 w and 1/4 w is going to give me 3/4 w. And negative 3 and 3 are going to combine to give me 0. And I actually don't have to write that 0, so my answer is going to give me 3/4 w. As we look at this one right here, we're going to start subtracting linear expressions. We want to find each difference. So again, as I go through this, we're going to be looking specifically at this piece right here. Okay? Now, there's two ways that we can go about doing this. We can do it vertically or we can do it horizontally. Okay? If we do it vertically, we can see that this is going to be 5x plus 6 minus negative x plus 6. Okay, so now we just go down the row. We say 6 minus 6 is going to give me 0, and 5x minus negative x is going to give me positive, so plus, right, plus 6. So that'd be 6x. So my answer should be 6x. Now if that confused you, that's fine. We can also do this horizontally. And that's my preferred method, is where we would go 5x plus 6, because this is as simplified as it gets. We're using addition. We don't have to include those external parentheses. Okay, and now I want to go plus. Now I have this minus sign here, but I want to use this plus sign, because we want to divide all of our terms up with addition. So if I use this plus sign, what I can actually see is right here in this space, I can do a negative 1 times by this quantity. So that'll be plus negative 1 times by negative x plus 6. Okay, so as I look at this, negative 1 times by x is going to give me positive x. Negative 1 times by 6 is going to give me negative 6. So I'm going to have 5x plus 6 plus x plus negative 6. So if I can combine my like terms here, I'll get 6x, and combine my like terms here, and that will give me 0. So my answer is just going to be 6x. So again, when we see this minus sign in between this parenthesis, so I have some blah over here and I have some blah over here. Okay, what I want to do is I want to change this minus sign right here into a plus sign. Okay, so the way that I would do that is I would still have this blah inside here, and I would change that into plus -1 times by this blah inside here. Okay, so what I'm doing right here is going to be doing the same thing in here. What I'm doing is I'm just changing this minus sign into a plus and -1. So that -1 will go inside here and it will change all of the signs inside there, which is going to be exactly what I need it to do. Okay? So as we look at this, okay, we're looking at our next problem here. We're seeing 7y plus 5. And then over here, I want to make this a plus, so I'm making this plus -2 times by this quantity over here. So plus -2 times by 4y plus -3. Okay, so that -3 became plus -3. So now this -2 can be distributed into this problem right here. So I end up with 7y plus 5 plus -8y plus 6. So now again I can look for my like terms. I can combine those like terms. I'll end up with -1y. I can combine these terms right here, and I can combine them, and I'll see that that's going to be 11. Okay, so as I add those together, this would be my final answer, -1y plus 11. Now, this -1y would kind of be like bad grammar. What we want to actually do is write it as a -y plus 11. So -y plus 11. So the original price of a cowboy hat is D dollars. Okay, you use a coupon and buy the hat for D minus $2. You decorate the hat and sell it for 2D minus $4. Write an expression that represents your earnings from buying and selling the hat and interpret the expression. So the first thing that we need to talk about is that D represents the original price in dollars. Okay? So we used a coupon, okay, to buy this hat. So we bought it for D minus 2. So we took the original price of the hat and we took away $2. So when we used our coupon, that's actually telling us our coupon says $2 off. Okay? Now we're decorating the hat and we're selling it for 2D minus 4. Okay, so we're selling for 2D minus 4. So what this equation is saying is we are taking the original price, D, we're timesing it by 2, and we're taking away $4. So we're taking the original price, we're doubling it, and we're taking away $4. And that's what we're selling it for. Okay? Now, what we want to do is write an expression that represents our earnings. Okay? So we want to take our profit. Now, our profit is going to be how much we earn, how much we sell it for, so our selling price, and we're going to be taking away how much we spent. Okay, and that's going to be equal to our profit. So how much money we walk away with, our profit, is going to be equal to the amount that we sold it for minus how much we bought it for, how much we spent making it. Okay? So how much we were able to sell it for minus how much we spent it on is going to give us how much money we're able to walk away from. So when we are walking away with this, we're going to say, okay, if I take that 2D minus 4 and I subtract how much I spent on this, which was that D minus 2, I should end up equaling out my profit. So I need to simplify this expression here and say, okay, 2D minus 4, I can write that as 2D plus -4, and that now allows me to drop out those outer parentheses. I can now say this is going to be plus -1 times by D plus -2. -1 times by D is going to give me -D. -1 times by -2 is going to give me +2. So I can bring down the rest of this 2d plus negative d is going to give me 1d, or just d. And negative 4 plus 2 is going to give me negative 2. Okay, so my profit is going to be d plus negative 2. So what that means is my profit is going to be the same as that original price minus those $2. So it kind of sounds right off the bat that we're not making any money. So if we run through this with some numbers, and let's just say our hat is $5 originally. D is equal to 5, okay? Originally the hat cost $5. So we got our coupon, we took $2 off, so we spent that D minus 2, so we ended up spending $3, okay? When we spent those $3 and then we sold it for this D minus 4, okay? 2D minus 4, what we're taking is that 2 times by 5 and minusing 4. This is what we're selling it for. So 2 times by that $5 gives me $10, minus that 4 gives me $6. So I bought it for $3, I'm selling it for $6, so I'm taking that $6 minus that $3, which means I'm walking away with $3. Okay? So that means in this situation, I walked away with $3, which means that I have just enough money to be able to go through this one more time. Okay, so go ahead and try these ones on your own. Once you're done with that, go ahead and come back here and see if your understanding lines up with mine. So as we look at this, we have m minus 3. I can rewrite that as m plus negative 3. Then this minus right here is going to become that plus negative 1 times by negative m plus 12. That negative 1 is going to be distributed into here and into here. So we have m plus negative 3 plus positive m, because negative 1 plus negative m is going to become positive m, plus negative 1 times by 12 is going to be negative 12. So now as I look at this, I can combine my like terms. M plus m is going to give me 2m. Negative 3 plus negative 12 is going to give me negative 15. So now I can say 2m plus negative 15 is going to give me my answer. Okay? Now as we look at this next one over here, I have this negative 2 out front. So I'll take this negative 2 and I'll times it by both of these things in here. I have this minus 5 right here, so I'll turn this into plus negative 5. So I can distribute this negative 5 into both here and here. So negative 2 times by c is going to be negative 2c, plus negative 2 times by 2.5 is going to give me negative 5. Now I take this negative 5 and I times it by 1.2c, so that's going to give me plus negative 6c. Now plus negative 5 times by that 4 is going to give me negative 20. So I can come back and look for my like terms. This negative 2c and that negative 6c can combine to give me negative 8c, and this negative 5 and this negative 20 can combine to give me negative 25. So as I come back and I flush this out, it'll be negative 8c plus negative 25. Okay, go ahead and try this one on your own as well. Once you're done with that, go ahead and check back here to make sure your understanding lines up with mine. So again, this problem looks just like our other one. We're selling our hat for D plus $2 this time, and we are buying it for D minus $2 this time, and the original price is D dollars. So as we look at this, we can set it up as my selling minus my cost, which is what I bought it for, is going to equal my profit. Okay, so I sold it for D plus 2. I'm going to take away how much it cost me, which was that D minus 2, and that is going to be equal to my profit. Now as I look at this D plus 2, that's as simplified as it gets, so I can write that as D plus 2. I want this negative sign to turn into a plus -1 times by this d minus 2, or plus -2. So this -1 can come in here and into here. So I have d plus 2 plus -1 times by d is going to give me -1d, plus -1 times by -2 is going to give me +2. So as I look at this d right here and this -d right here are going to cancel each other out, and that's just going to be 0. And then this 2 and this 2 are going to add together to give me 4. So my answer is 4. Now this is interesting because that means I have a $4 profit, and that is a $4 profit regardless of what the original price of this hat was. If it was $25 and I bought it for $23, and I bought it for $23 because I did d minus 2 for what I could buy it for, and I sell it for d plus $2, that means I'm going to take that original price, 25 plus 2 is 27. So I sold it for $27. What that means is this 27 minus 23 is going to give me $4. So I earned $4 for that $25 hat that I could have bought. Okay, so go ahead and try this mini assessment on your own. Go ahead and put it in your notes, and I will check for this on Friday.